Okay, next we're going to talk about the logical modeling for Infocubes for transaction data. Okay, the classical star schema is a commonly used model for this purpose. Okay, as shown here, very effective requests can be made in the star schema. Okay, very easy to understand. But the question is it flexible? Okay, and we'll talk about the drawbacks of the traditional star schema later on. Okay, but next we're going to take a look at one common example of a star schema, and then I will also use this as an example to illustrate the size of a data warehouse briefly. Okay. Now, on this example, we see that we have a fact table in the middle, sales fact table, okay, or sales transaction, if you will, which is connected to 1, 2, 3, 4 4-dimension tables. Okay. So you have item, you have location, you have branch, and time. Okay. So this is what they call star schema. You have one fact table in the middle connected with several dimension tables. All right. Now, one of my favorite exam questions is that, what is the relationship between a dimension table and the fact table? Okay. So consider the relationship between time and sales fact table, for instance. Okay, what is the relationship between time and sales? Well, if you recall earlier in the MERM model example, we talked about we've seen a similar example between customer and sales, and between material and sale, and so on. Okay, so if you remember, that is a 1-to-many relationship, then that is the correct answer. Okay, so if there is a 1-to-many relationship, we then put, generally speaking, put the primary key from the one side, in this case, the time key, into the many side, which is the sales fact table. Okay, so that's why you see time key repeated in the sales fact table. Okay, it is actually color-coded green, which is very good. And similarly, if you look at branch, the primary key of branch is branch key. Okay, and again, branch key is duplicated in the sales fact table. Okay, again, color-coded in blue. All right, and similarly, item key is duplicated there, and so is location key. Okay. So in other words, in the sales fact table, the primary key is a composite primary key made of the 4 primary keys of the dimension tables. Okay, in database terminology, we also say that the primary key of the sales fact table is made of the foreign keys. Okay, because time key is a foreign key in the sales fact table that corresponds to the primary key in the time table. Okay, so the composite primary key is made of 4 foreign keys, in other words. Okay, in the rest of the fact table, you have then 3 key figures, if you will. Okay, in BW's terminology, you have unit sold, dollar sold, average sales. They are, by the way, are normally known as measures in the data warehousing field, but known as key figures in BW. Okay. But notice that since we are replicating the primary keys from the dimension tables into the sales fact table, that means that the fact table is going to be very large. Okay, it's going to be a combination of your fact tables. All right. So for instance, in a even a mid-sized retail chain, okay, your grocery store or retail store, whatever, think about how many items that they typically carry. Okay. Again, we in a typical mid-sized retail store, you probably have 100. No, I shouldn't say 100, but probably tens of thousands. Okay. Let's just use a figure of 50,000 items. Okay. So you might want to write this down because I'm going to show you how to calculate the size of a data warehouse here. So let's say we have 50,000 items for sale. Okay. And then we are a national chain, so let's say we have 2,000 stores or 2,000 locations. Okay, so 50,000 items, 2,000 locations, and then we have let's say 50 branches. Okay, in 50 states. Okay, just a simple example. So again, 50,000 items, 2,000 stores, and 50 states. Now, if you multiply the three numbers together, okay, because we're going to have combinations of different items in different stores, in different branches, and so on. So in the fact table, it is possible to have how many records based on the combination of the three. Okay, so we multiply 50,000 by 2,000 and then by 50 states. Okay, and the answer is 5 billion. Okay, so the 5 billion combinations or 5 billion records. Okay, so that's a very large table. Okay, and then the question is next question is in terms of physical size, how big each record is. A conservative estimate is let's just use a number of 8 bytes. Okay, a very conservative estimate. So 5 billion times 8 bytes, and that gives you 40 gigs or 40 gigabytes. Okay, so that's 40 gigabytes of data right there, without considering the time dimension. Okay. And then if we bring in time dimension, let's say you want to keep track of your sales on a daily basis, okay? So let's say we have 360 days open for business. So 40 gigabytes times 360 days, you get 14. Let me see, 14,400 gigabytes or 14 terabytes. Okay, so that's how you get a typical data warehouse in the range of couple of terabytes to hundreds of terabytes, or even the next level up, petabytes and so on. Okay, so that's a simple example of the size of a data warehouse using a traditional star schema to illustrate. Okay. Now, star schema is very popular. It is also used in the industry as the logical model to describe various data warehouses. Okay, but it does have some significant problems. As shown here, one, no support for multiple languages. Okay. Two is that you have alphanumeric foreign keys. Okay. Again, the foreign keys are the primary keys that are duplicated in the fact table. So basically, if we go back to the previous example, if the location key is XYZ, 123 as a location ID, then that is going to be used or duplicated in the fact table as well. Okay, so whatever alphanumeric keys that we use will be duplicated in the fact table. Third drawback, no support for multiple time periods, basically, okay? So it is not possible to store master data for different time periods. And finally, your hierarchies or hierarchy and relationships have to be modeled as attributes as opposed to a separate table, okay? Well, some of you probably recognize that a lot of the drawbacks are corrected in SAP BW, okay? That brings us to the next slide. In the SAP BW, which uses what they call expanded star schema. Okay, so it is kind of like star schema, but it has some important differences. One is that dimension characteristics are now separated into different segments or different tables. Okay, your attributes, your tags, your hierarchies now have separate tables, right? So now we can have multiple languages, multiple time periods, and so on. Okay, the advantages that we talked about before for BW models, and also another important advantage that we have also touched upon is the introduction of SID or surrogate ID. Okay, so instead of using the real-world keys, which are oftentimes alphanumeric, which are long and complicated, and take up a lot of storage space, BW instead uses surrogate IDs, which are very easy to process and very efficient, and also can provide the link between master and transaction data. All right. Okay. Here on this slide, we talk about master versus transaction data again, but another way to think about the difference is that according to SAP, we have master data, also known as solution independent data, okay, or characteristics, because you need to have that kind of data no matter what kind of solutions or transactions you're talking about. Okay, so solution dependent data are normally known as transaction data, or basically the fact tables and dimension tables that make up your Infocubes. Okay, so each Infocube basically provides a solution to a business problem. Okay, whether you're talking about a sales transaction, or you're talking about a purchase transaction, or you're talking about HR transaction, and so on. Okay, so each Infocube is designed to solve or to provide solution to a particular business problem. Okay, but at the same time, you have a lot of solution independent data or characteristic that exists independent of your solutions. So surrogate ID or SID is a very important concept in SAP BW. So let's take a look at them in more detail. Each surrogate ID is an artificial primary key. Okay, in other words, it's a technical key generated by BW automatically. It is not a key used in the real world for production purposes. Okay, so it's a technical key instead of a production key. And each key is very short, only 4 bytes long, represents a whole number. So it's an integer. Each key is an integer. There's no fractions to work on. So it's very fast, very efficient to process. And also notice that the surrogate keys or SIDs provide the link between an Infocube and characteristics, as can be illustrated in figure 5.6 on page 160. Okay, now I don't have the figure to show you here, but if you go to the book just take a look at the right-hand side, say the material dimension. Okay, the material dimension has two lines coming out of it, okay, if you will. One is from the SID table for material to material dimension. Okay, in other words, the material dimension is connected with the SID table for material through SIDs. Okay, so in the SID table, for instance, the materials, we have 5 materials there, and the SIDs are 1, 2, 3, 4, 5. Okay, so in other words, say we have 5 different materials for sale. But in the cube, we have sold only 2 materials so far. Okay, so if you look at the material dimension, under SID material, we have 3 and 1. Okay, so we have sold material 3 and we have sold material 1. All right, so we can connect and find out which materials that we have sold through the SIDs. Okay, because SID 3 means M3 based on the SID table, right? And then SID 1 means M1. So we can easily find out which materials have we sold through the SID table. All right. Similarly, from the material dimension to the material group SID table at the bottom, the connection is also made through the SIDs. All right. Again, for material group, we have, let's say, 3 groups. Okay, material group 1, material group 2, and material group 3. And they are, the keys are 1, 2, and 3. Okay, and even though we have 3 material groups, but so far in the cube, we have data only for 1 material group, right? Material group number 3. But again, connection is made between the Infocube and characteristics through the SIDs. Okay, so based on the SIDs, we can find out which materials from which material groups have we sold, and we have data, we have sales data stored in the Infocube. Okay, so that's the connection right there. And not only that, the SID table also provides the link between characteristics and the corresponding attributes, tags, and hierarchies or hierarchy tables, which is illustrated in figure 5.5 in the book. Okay, so it will become clearer everything on the next slide, but here briefly, I hope you can understand that a connection between Infocube and characteristics is provided through SID tables, and then from the characteristics, from the SID table, the connection is also made to the actual attributes, tags, and hierarchies. Okay, so everything is linked together from the Infocube, which has transaction data, to characteristics, which have master data. You see that again in the middle we have an Infocube, one fact table connected to several dimension tables, right? And then from the dimension table, you have a connection with an SID table. Okay, so if you look, pick any block, surrounding block, for instance, on the upper left-hand corner, let's say we have a material master data SID table. Okay, so you have material SID table shown in green at the upper left-hand corner. Okay, and the SID table is connected to the dimension table. At the same time, it is connected to hierarchies, it is connected to tags, and connected to master data attributes. Okay, master attributes data. Okay, so again, the SID table is very, very important in SAP BW. Okay, it provides the connection between master data and transaction data, right? From SID table to the Infocube. Okay, and also it provides the connection or the link between the SID table to the attributes, to the tags, and to the hierarchy tables. So this SID, the surrogate ID, is the link that connects everything together. And this way, it allows the reuse of master data. Okay, because right now we see one Infocube in the middle. Let's say for sales transactions. All right, but you can also imagine that we can have another cube. Let's say somewhere at the upper right-hand corner, we can draw another cube for purchasing transactions. Okay, when you're dealing with your vendors, placing purchase orders and so on, you need to keep track of your sales order, orders processing and so on. So you have another queue up there, and that particular queue can connect to whatever master data that we need to have through the SID tables. Okay, so you can have a connection to the material master. You just draw another line to reuse the material master data. Okay, so this way we don't have to replicate the actual data multiple times in the system. Okay, we just store the data once, but the connection can be made multiple times through the use of SIDs. Okay, so that's one big advantage of SAP BW over other data warehouses built on the traditional star schema.